Is the formula of correlation coefficient in the formula sheet?
Don't know.
Is it right or what?
No, it is right, but I remember, if you remember, I said they write it differently in the book.
Yeah.
Yeah. So it's right, but it's not the way I used it in class.
But I got the difference.
Then something went wrong in your calculation. But why are you doing correlation coefficient?
The first one.
Oh, okay. Worry about that.
I was doing it by the formula in the formula sheet, and it was different. So I used the one that you gave us.
Good. You used that one.
Yeah.
Good. Okay, let's have a look here. What are the numbers? 20, 27, 15, 35, 29,
30,
yeah,
22,
yeah,
32,
yeah.
30,
Oh, there's more. Oh, great.
25,
30 and 25. Okay, so the average here, let's see, 27 plus 15 plus 35 plus 29 plus 30 plus 22 plus 32 plus 30 plus 25. That's 2, 4, 5 divided by 1, 2, 3, 4, 5, 6, 7, 8, 9. 27.2. For the next part, we'll need to use this, so I might as well write it down. 741.05. And for the last part, for the next part, I need to calculate this. Now, engineers, warning. Engineers, you stop here. That's the end for you. Okay. Right, business students. So, 27 squared, 729. This is 225. This is 1225. I can't do the other one in my head. 841. 900. 484. 32 squared is 1024. 906.25. I hope. 729 plus 225 plus 1225 plus 841 plus 900 plus 484 plus 1024 plus 900 plus 625. 6953 over 9. 772.56. So the standard deviation is square root 772.56 minus 741.05, which equals 5.6. Yeah. Yeah? It's long, but it's not difficult. It just takes time on the calculator, that's all. Which is actually good for the exam, because, it gives you marks, which is what you really need. Okay, continue. So, A1 is okay, A2, A3. We'll go back to A3 later. Engineers, you had to do partial fractions as well, didn't you? Yeah. A6, please. Now, I think, Victor, you were asking me before, maybe, or maybe it was Marcelo, if they always give you the factors. Now, you can see this is an example where they give you the factors, but they don't tell you the ABC. So you have, I think you have a choice here. Yeah, you could have a B or a BX. I think I know what people will pick those. Finished, Tony? Okay, nearly ready for this one, 6? Yeah. Let me just write it down first. Okay. X plus 5 over x plus 2 squared x minus 4. Right, so I'll start with the x minus 4, just because, reasons, I don't know. A over x minus 4 plus b over x plus 2 plus c over x plus 2 squared. When you multiply, you get x plus 5 equals A, x plus 2 squared plus B, x minus 4 x plus 2 plus C, x minus 4. Right, if I want A, I should make x equal to 4. So that gives me 9 equals 36. A. Ugly. So A is 9 over 36, which is 3 over, 1 over 4. Yeah, 1 over 4. Okay, what should I do next for x? Minus 2. So I get 3 equals C times minus 6. Also ugly. C equals minus a half. Blah. And lastly, x equals 0. So I get 5 equals 4a. Oh, that's okay. Minus 6b minus 4c, which is minus a half. Yeah, so that makes it a plus. Is that okay? What's minus what? Minus 8b. Of course it is. When did I say 6? Right, minus 8b. Okay, so let me see. That cancels that. So I get 5, and that makes that a 2. So I have a 3 here. Minus 3/8? Hang on. 5 minus 1 is 4. 4 minus 2 is 2. 2 divided by minus 8, minus a quarter. Yeah. So B is minus 1 over 4. So the answer is, you should have this, A, which is a quarter over x minus 4, plus B, which is also a quarter over x plus 2, and then C is also minus a half over x plus 2 squared. How many marks is that actually? 4. That's okay. It's okay. Okay.
It's better than the one with the graph.
Yeah. Okay. You'd rather 4 marks for this than the graph. Okay. I mean, there's nothing different about it. It's just the usual story here. Right. 7. What do we need for 7? What rules do we need for 7? Come on. What's it called? No. I give you a clue. It was the first and second lesson of semester 2. Product rule and quotient rule. I don't really need the chain rule except maybe for the E4x. It's really product and quotient rule. Now, please note, usually they don't ask you to simplify, but in this question, they do want you to simplify. Okay? So, you're not finished when you have the answer, you have to simplify your answer. Okay, so try that. E4x is actually in the formula book. It's 4E4x. So.
The bottom one?
X cubed cos x means the product rule. No, quotient rule first. So why are you finished? Well, I mean, the quotient rule happens first, and then in the quotient rule, you'll need to use the product rule. So we start off with the bottom square, the bottom times root of the top, and so on. Albert, you're finished? What do you think? Do the what now with the what? Oh yeah, as part of your calculation, Joe. Finished. 5 minutes. Hang on, we're not all engineering students. We can do this faster than 5 minutes.
4 minutes.
Yeah. Yeah, be quiet. Right. Are we ready to look at it now?
Yes. Oh my God.
I'll give you one.
Okay.
Your mistake was coming to class. That's where it started. Huh? Victor? Finished? The right? Could be. Maybe. We'll have a look. Okay, what's on the top? E for x, and on the bottom? X cubed cos x. Right, so first we need the quotient rule first, which is the bottom squared, the bottom times the derivative of the top, which is 4e 4x, minus the top times derivative of the bottom, which is a product rule. Yeah, which will now be 3x squared cos x minus x cubed sin x. So our job now is to clean this up. We'll have 4x cubed e 4x cos x minus 3x squared e 4x cos x plus x cubed e 4x sin x all over x6 cos squared x. The bottom stays like this, because in the quotient rule it's just the bottom squared. Now, if you look here, this can be put together with this. There's 4 of these and 3 of these. So together, there's 1 of them. So you're left with x squared. Oh no, sorry, I can't put them together because is there anything I can put together? No. The best I can do is divide everything by e4x and x squared. Yeah. I don't really think there's much I can do to simplify it. On the top I can take out x squared e 4x and I'm left with 4x, yeah, cos x minus 3 cos x plus x sin x. There's nothing I can do to simplify. I guess I can cancel here though. Cancel this to make it x4. And get rid of this. But that's it. So the only thing I can do to simplify is to cancel by x squared. Can't see anything else.
Divide by 4, is it?
Yeah, I guess if you...
You get over cos x, and the last one you get 10 over cos x.
Yeah, is it simpler though? I don't know. Let's see what they did. I feel like maybe the only other thing to do is take out the cos x here. So you can have e for x bracket cos x bracket 4x minus 3 plus x sine x. And maybe they left it as x squared cos x squared. Well, let's see what the marking scheme says. This is version 1. What number was it actually? 7, okay. Yeah, I did more than I needed to. Yeah, so I didn't need to take the cos x out, and they didn't put the square back here. So their answer was more like here. They stopped here. But if you continued, I'd still give you the marks for this. Okay.
We didn't even get.
If you just stopped here.
No, below.
Here.
Yeah.
Let's have a look. It's 2 marks for the derivative and then 1 mark for opening the brackets, is it? No, it's 3 marks in total for the derivative and then 1 mark for simplifying. What's wrong with you?
The math on rock is like.
Yes? It's not me, by the way.
When you divide the mark, it's like say 3, 4, 3.
Sometimes the marks are a bit strange. Sometimes. What? Right. Try 8. What do we need for 8? What rule do we need for 8?
Okay, we have
We cannot. What rule do we need for 8? No, not 8? Yes, substitution. You're right. Very good. That is a good question. What do you think? Let u equal. Nope.
X squared.
Yes. X squared. What do you think? Well, it stays with me.
put the limit in U or X?
Now, you have to be careful. If you have it back as x, you can use the x limit. But if it's in u, that 1 and 2 is for x. X is 1 and x is 2. So you can change them into u values, but what I usually do is just put everything back as x. We can look at it now. Is this it? Yep. Okay, so first we say u equals x squared. Du dx equals 2x. Du over 2x equals dx. I can take this and put it in. I can take this and put it in. So I get 1 to 2, 2x EU du over 2x. That's great because they cancel and I'm left with 1 to 2 EU du, which is EU 1 to 2, which is EX squared 1 to 2.
E4.
Yeah, which would be E4 minus E1. Do they want exact or decimal? Doesn't say. So you can leave it like this if you want. You have it as a decimal, Malik? What is it?
51.88.
Okay. Yep. Do we want to do 9? Andy and Haran, do you remember if you did weighted averages with Joan? Weighted averages? Are you sure?
Yeah.
Let me just double check. I'll ask somebody who listens in class. So do you remember doing weighted averages with Joan? Weighted averages? Okay, I believe you.
Even if I don't remember how to do it, at least I would remember the word. I don't even know the word.
We didn't know.
Okay. Now, number 10 is confidence interval. So you and you and you, we did confidence intervals yesterday. The only word which you don't maybe know is, you see here, it uses this word called variance. You see that word, variance? Variance of 16.
What confidence you don't do either?
Didn't we? Have you got your book?
1.93.
Yeah. Have you got your workbook?
Oh.
Don't say, hang on, you make this bad for you. This is going to be so awkward.
He said the limit is for X, not for you.
Yeah, that's what it says. No, it's not.
It's X, it's X squared. U is X squared.
Yes, we did do confidence intervals on page 52. 52. Try it. This is why we're doing revision. See how much you remember. Now, engineering students. Engineering students. This word here, variance. And business students. This word variance. Does anyone remember what it is? Yeah, variance just means standard deviation squared. So if it's 16, then what's the standard deviation? It's 4. That's all. Okay? Right, try this. Try it, Harry. You have, let's see, the variance and the mean is there, 9.2. Let's see how much you remember. This is, if you need to open up your notebook, this is in page 52. We did it at the end of normal distribution. Now, I don't know why the letter is missing. It should say, find the confidence interval for mu, the average. In other words, the question says, find the confidence interval. Dude, we did this yesterday. Yesterday! Alright, I think this is something I have to do.
Yeah.
People are being stupid right now. Right. Since most people forgot, please watch and listen carefully, okay? Watch and listen, not talk, okay? Yes? Great. So, the confidence interval for the true average, we say that it is smaller than the average we get from the data plus 1.96 standard deviations over root n, and it's bigger than the average minus 1.96 standard deviations over root n. So in this question, the average, what was it? 9.2, the n was 10, and the standard deviation was 4. Okay, so can you calculate this, please? Calculate the two limits. Use your calculator and the formula in front of your face and get the answer. Thank you.
What does 1.9? What does it mean?
We were talking about this yesterday. Yesterday. Yeah. Confidence interval is like the uncertainty in physics. Remember this? Make me tired and hungry. I think this is in the formula book. I know. No, but I just saw it in the engineering one at least. It's not in the book? Alright. Right, what's the upper limit? No. It's in the book. Listen! The formula is in the book. Which is good. Malik, no, you don't need to check. Tony just showed me. It's in the book, okay? 11.68. And then for the lower limit, 6.72. So what you're saying here is that the true average is between 6.72 and 11.68. The average we got from our sample was 9.2. But we understand that it's a sample, so it's not going to be exactly right. So the true average is somewhere between these two numbers. Okay? That's great. I shall get a medal for you tomorrow. Right.
Is it like this predicted with an increase in the number?
Yeah, what happens with n? When you increase the n, the boundary gets smaller and you become more accurate. So the bigger the sample, the smaller the range of possible values for n, for u. Yeah. Yeah. Now like I said, there's a letter missing from this when they typed it. The mu. This letter here, that's missing from the end of the sentences. You see, it's got cut off from the printing.
What is the 95%
What do you mean, what does it? Oh, 95% means that we're 95% sure or confident that the true value is between these two numbers. So it's like a probability, how confident you are that the true value is between the two numbers. Because it's still possible that the true value is outside these two numbers.
It's not like to make you complete.
No.
Why did they put it?
No. You see, this is not what you should be thinking. You should be thinking, how can I study this because I have an exam in 2 weeks? You shouldn't be questioning it. Yeah? Which one of the following statements is true? Okay, so let's have a look at the statements. Okay, 95% of the distribution is to the left of mu. 95% of such intervals would contain mu, and there's a 95% chance that the mean of the 25 items is in the interval. Which one is it?
D.
No, it's not C, because
D.
C is completely wrong. There's not 25 items. How many items are there? 10. So we know straight away it's not C. Okay? We definitely know it's not C. So it's either A or B. B. It's B. Well, thank goodness for that. Right. We'll yeah. Yes.
Yeah, this one.
Right, this is part of B2, the second half of B2. I want you to try this. Now, listen, I taught you this in semester 1, and I think Joan and Roland taught the engineers the probability trees in semester 1 as well. So, although it's in semester 2 of the syllabus, most teachers do it in semester 1, okay? So it could be on your engineering exam because it's a semester 1 topic. Yeah. So, in other words, everybody here could get this question on their exam. And I think everybody will get one question with a probability tree on their exam. The only difference is, engineers, I think you will get your question in section A. And business students, I think you will get your question in section B.
Don't we have the same section? Like for...
No, because the topics aren't the same. So section A is a mix of both semesters. So section A won't be the same. So engineers, you'll get this in A, I think, and business students, you'll get it in B.
But ours can be semester 1 and 2.
Yes, A and B is 1 and 2. Yeah, but I'm just saying that in engineering, I think they usually make it a smaller question, so they'll put it in A. Business students, they usually make it a bigger question, so they put it in B. Okay? So can you try this probability tree? What? Yeah, that's the lower one. But I asked you for the upper one first.
Oh, okay. So there's 6 points on the side.
It was. But
So when you said no, I thought it was wrong.
no, that's not.
Oh.
You gave me the second answer first.
Oh, okay.
No, don't talk, please. There's a lot of text to read, so just read it and write the information down.
Can you make it...
You want me to zoom in?
Yeah. There's our one.
Whoops, hang on, I'll zoom in now. How's that? Can I do it full? No, I'll leave it like that. To the question? Yeah. Well, just write the question down and then I need to go back to the text for other people. Can I go back with this? Yeah? Okay. finished, Tommy? Okay, will we have a look at this one then? Farid doesn't finish work until 10 p.m. 2 times out of 3 he goes home by bus. So that means here is 2/3 and here is 1/3. So let me just draw that first. So first is bus and the second is walking, isn't it? 2/3 and 1/3. When he gets home, he either watches TV or he goes to bed. When he travels home by bus, then 3 times out of 4 he goes to bed. So this will be 1/4, 3/4. So we have TV and bed, 1/4, 3/4, and then next is if he walks home, then he always goes to bed. Okay, so TV, yeah. Stay calm, Stephen. Stay calm. Right, like this. Yes. Complete the diagram. Right, that's what we've done. So the first question is: calculate the probability that on a night after finishing work, he travels home by bus, then watches TV. So the probability that he travels home by bus and then watches TV. So this is, I'll just write down probability of bus and TV, which will be 2/3 multiply 1/4. Yeah. Yeah. Okay, and then the next one is, given that he goes straight to bed, what is the probability that he went home by bus? So this is the probability that, let's see, given that he goes straight to bed, what's the probability? Yeah, that he took the bus, given that he went straight to bed. Now this one is a little bit trickier. There's 2 ways you can do it. You can do it by using a table, or you can use a formula. What did people use? Use formula, was it? Yeah? Huh? Neither. What did you use? Okay. I'll do it both ways for you. Okay, so the first way I know we did in semester 1 is by using a table for sure. Okay, so if we look at a table here, it's already familiar. Yep. So what's our choices? We have here TV or bed. TV. Yeah, TV or bed. And well, hang on, I need to make this a bit more spaced out. TV and bed, and then here bus and walk. Okay, so we have this one here, which is bus and TV, 1/6. So as a percentage, if you want to put it as a percentage, 16, isn't it, or something? Yeah, 16.67. So 16.67% of the time, you take the bus and the TV. Now what about walking and TV? 0. Bus and bed, it's 2/3 multiplied by 3/4. 6, is it half? 6/12, half. 50% of the time. And then the last one is walk and bus, which is 33.33%. So in this calculation, you know he went to bed. So it means you're only looking at these 2. So the answer would be 50 over 50 plus 33.33. So what's that then? 0.6. That's the answer. Now, if you didn't like that, you can use the formula. So does anyone remember the formula here? So, or, you can do this formula. Probability of bus and bed over bed. Now this is nice because we know the top already, don't we? Oh no, we don't. We can calculate it, yeah. So what's probability of bus and bed? It's 1 over 2. And probability of bed will be bus and bed, which is 1 over 2, plus walk and bed. 1 over 3. So, well, it should be the same. It'd be a problem if it wasn't the same. So this way is by using a table, and this way is by using the formula. Yeah. Now, engineering students, this is a little bit too difficult because, like I said, they usually put this in section A. So if this was a section A question, they would just ask you for this part. Just one part. What's wrong? That is walk and bed. Bus and bed, yeah. Continue. It's 7 minutes. No.
Wait, why don't we do mappings and functions?
What are you complaining about now? What's wrong?
Why don't we get to the mappings and functions and vectors? What problem is it?
Right, let's have a look at another paper then. Yes, I can tell the time. Thank you. I have a pain in my neck is what I have. Right. These are too similar. Now let's go to something more exciting. 2012, maybe that was more exciting. We'll continue when I don't have engineers with more probability, okay? I only want to do the ones that they've seen as well. I wish I could. Right. This one, too similar, yeah? No, because engineers don't do binomial. There's integration by parts, and then I want to do a normal distribution. Oh, hello. This looks like it could be fun. Yes, B4. It's also confidence interval and normal distribution. Perfect. Actually, yeah, let's start with B4. So this is, what year is it? 2012, version 2. No. You can see here, this means 2011 to 2012, so the exam was in the summer of 2012. So this is 2012 version 2.
Wait, why is it 1, 1, 1, 2? Oh, no, never mind.
Mm-hmm. For the Z transform, it's
X minus mean over standard deviation. You have X, 1.60.
yeah, so it'll be 1.80 minus 1.75 over 0.2.
Do we use the table?
Mm-hmm. Now you can take out the table. This is the normal distribution questions with the bell curve. You have to use the table book for this. You don't remember? You can get one online if you want. Just type in normal distribution table book in Google Images. Oh, you have one? A good drawing of the bell curve will help you. So often what happens when you have a minus value is because it's symmetric. You can look for the value, the appropriate value on the right. Do you know what I mean? Like here you have it's minus, is it? So draw the line straight there. Now you want more than 180, so you want all of this area, which means you would like to know what this one is. But this would be the same as this. But the table book gives you, and so on.
So it's 1 minus the overall.
It depends which way you drew it, but there's going to be a few 1 minus in it. Question? Yep. We'll see. We'll see when I do it. Your question is, in other words, what do I do? Yeah.
D as well, or just A?
All of that, yeah.
Binomial distribution, D, yeah?
Oh no, this is all normal distribution, I think.
So they give you the number.
No, it's only 1 mark, so it's not something with binomial. It's not. It's just something with percentages. What answer did you get for A part 3, Malik?
0.05.
So 5%. So you're saying 5% of people are between those heights. So if you have 150 people, that tells me there should be about 7 or 8 of them between these heights. Yeah, 8 then, yeah. It's a 1 marker, so it should be something pretty quick. I'm going to do the answer tomorrow for this whole question. So wait. I want you to finish this at home. So you have 2 choices. You can either take a picture, or you can just open up the video later. It'll be the last part of the video. Sophie, do you want to see what we're looking for? I know you don't feel to, oh, you want to email me or something? You'll email me? Yeah, okay. Okay, so you come by at 1 o'clock, because I need some Stephen time where I don't have any students to relax. At 1 o'clock. What time is chemistry at? Come at 1 o'clock, okay? You'll send me an email. Yeah, I'll go home at about 4:30. So if you send it to me like at 1 or 2 or something, I can reply. Fine. Just get out of my face.
You have more students right now.
Yeah, that's true. But my Stephen time is going to be used for doing corrections. Coursework. I'm planning to start today.